Alright, so this video we're evaluating a bunch of definite integrals using the fundamental theorem of calculus. So to use the fundamental theorem of calculus, you look at your integrand in each case and you have to determine an antiderivative. And so our first case here, 2 minus 2x, the antiderivative of 2 is 2x, and then the antiderivative of 2x is x squared, right? And I think we did this one in class as well. You can double check your answer, right? If you take the derivative of this, you should get back to the original here. So the derivative of 2x is 2, and the derivative of x squared is 2x. Good. And then we evaluate from minus 1 to 4. And so if we plug in 4, we get 2 times 4 minus 4 squared minus, and then plug in minus 1. 2 times minus 1 minus 1. Okay, so we get, let's see, 8 minus 16 minus 3, it looks like, huh? So that's 8 minus 13. Hang on one sec. Okay, so just finishing this off, 8 minus 13 is minus 5. Good. So now, continuing, we take the antiderivative of sine. Now, should this be positive cosine or negative cosine? The derivative of cosine is negative sine, so therefore I need to put a negative in front of my cosine. And then I'm evaluating from 0 to pi over 2. Right, so this is going to be minus cosine of pi over 2, and then minus cosine of 0. And so this would be a plus, so let's go ahead and just put a plus there. Okay, so cosine of 0 is 1. Cosine of pi over 2 is negative 1. Oh, sorry. I was thinking cosine of pi. So here's our little graph of cosine. Yeah, this is 2 pi. This be pi. This be pi over 2. So cosine of pi over 2 is 0. So this is 0 plus 1 equals 1. Good. E to the x, the antiderivative of is e to the x, evaluated from 0 to 1. So that's e to the 1 minus e to the 0, which is e to the 1 minus 1. Good. This next one, x to the 5th. This is the antiderivative would be x to the 6th power. You add 1 to the exponent, and then you need to multiply something to get a 1 there, so that would be 1 over 6. Good. And then we evaluate from minus 1 to 1. So that means you plug in 1. If I plug in a 1, I just get 1/6. And if I plug in minus 1, I get minus 1/6. Oh, plus 1/6. So that's 1/6 minus 1/6 is equal to 0. Good. 3x cubed minus 2x squared minus e to the x. So the 3x cubed here, what am I going to need to do to make that x to the 4th? And if I do that, I need 3/4 out in front, so that when I multiply this through, I get a 3 there. Minus, and then for the x squared term, I need an x cubed, and so that'd be a 2/3 in the front. So again, when I multiply these two together, when I differentiate, I get a minus 2 out, minus e to the x, and now we're going from 0 to 2. Okay, so now if I plug in a 2 for everything, let's see, what's 2 to the 4th power? That's 4 times 4 is 16. Excuse me. And so 3/4 times 2 to the 4th, I'll just go ahead and write it that way first, minus 2/3 times 2 cubed minus e squared. And then if I plug in a 0, I get 0, 0, and minus. So minus e to the 0. Good. And now let's see, what do I get out of this? Let's see, this one doesn't simplify. This one does. That's 3 times 4. Isn't that a 12? So 12 minus, and then that's 8 times 2, 16 thirds, minus e squared, plus 1. Let's see. So can we simplify that a little bit? Let me pop that into my calculator. Okay, I think that's probably fine to just leave it as, let's see, that's 36 minus 16 over 3, so that's going to be 20. If I just write it as 20 thirds minus e squared plus 1, maybe I should incorporate those two together. That'd be 23 thirds. I think that works. Good. I'm running out of space. I'll see if I can fit it in there. Alright, so if I put that in my calculator, I get 0.222776. Good. So this is a fine answer, by the way. Okay. What's next? Let's see, we've gone about 6 minutes. I think we've got time to do the handout too. Let's take a look at the worksheet that we have. I better pause this while I find it. Alright, so I don't know if this is very clear. For some reason this lens doesn't focus very good. Let's see if I can switch that around. Let's see. Is that coming into better focus? My hand is coming into focus. I guess you can't read for some reason the text isn't coming into very good focus. Let me try that again. Okay, that's a little bit better, I think. Let me flip that up. Okay, this is pretty low-tech stuff here. Okay, hopefully you have this copied off next to you. So let's just go ahead and do these one by one, see how many we can do in the next few minutes. So number 1 is the integral from -1 to 2 of x squared minus 2x. So let's write that down over here. -1 to 2 x squared minus 2x. Oh, isn't that the same function we had before? A little different. Okay, oops. So we want the antiderivative. So that's x cubed, and then I need a constant in the front so that when I differentiate I just get a 1. So that would be the 1/3 minus, now this is going to be x squared because the derivative of x squared is 2x, and then we evaluate from -1 to 2. Okay, and so if we do that we get, let's see, 2 cubed over 3, which is 8 thirds, minus 4, minus, now I plug in -1, and that'll be a -1/3. And then if I plug in a -1 there, it's a +1, so that's going to be a -1. Good. And now we just simplify that a little bit. Let's see, that's 8 thirds plus 1/3 is 9 thirds. 9 thirds is 3, so that's 3 minus 4 plus 1, I guess, huh? 4 minus 4 is, is that 0? I say 0 and I write a 4 for some reason. Good, so the first one is 0. Now the next one is the integral of x to the 100th power from -1 to 1. So let's go ahead and write that down over here. The integral from -1 to 1 of x to the 100 power dx is, well, you take x to the 101 power, 1 divided by 101 from -1 to 1. Let's see, this is an odd power, right? So that's going to be 1 over 101 when I plug in a 1, minus, and then it's going to be a minus 1 over 101, which is 2 over 101. Good. Now, let's see, the next one, 1 to 9 square root of x dx. Okay, before we anti-differentiate, let's rewrite that as x to the 1/2 power. And then we'll rewrite that. Now we can anti-differentiate. That's x to the 3/2 power. And then in front, I need something so that when I multiply by 3/2, I get a 1. So that would be 2/3. And then from 1 to 9. Now remember, this is the square root cubed. Square root cubed. So when you go to compute this, we're going to have 2/3 times the square root of 9 cubed. So I'm going to go ahead and write it that way. Square root of 9 cubed minus 2/3, and then square root of 1 cubed. Good. So that's 3 cubed, which is, well, it's 3 squared because I've got a 3 down here. So that's 9 times 2 is 18, minus 2/3. Let's see, so, oops, hang on. Okay, so let's see, on my calculator I see, we could work out 18 times 3, right? This is 54 minus 2 over 3, if you work it out. So that's 52 over 3. Okay, so there's the first 3 problems on our handout. Let's see how we're doing on time. 11 minutes? That's pretty good. Let's see, we've got our first 3. How about the next one? E from -5 to 5. So this one's kind of a tricky one, right? Because E dx, this is a constant. Whoops. This is a constant, so that's e times x from -5 to 5. And so that's 5e minus 5e, which is 10e. Good. Next one. So this one is also a little bit tricky in that you have to do a little bit of work first. And the work we want to do is we want to simplify that. Notice that that's a plus b times a minus b. So if you multiply this through, I'll go ahead and multiply it out this time again. Oops, minus 1. That's u squared minus 1. And so this becomes the integral from 0 to 1 of u squared minus 1 du. Okay, so again, this has to be a 3 power when I take the antiderivative and 1/3 minus u from 0 to 1. So when I plug in a 1, I get 1/3 minus 1, which is minus 2/3. Notice when I plug in 0, I just get 0. Good. All right. And let's see, the next one is the integral from 0 to 3, e to the x dx. So that's just e cubed minus e to the 0, which is e cubed minus 1. Good. Similarly, let's see, minus pi over 4 to pi over 4, cosine of x dx. That's just going to be the sine of x, right, because the derivative of sine is cosine. And then that's minus pi over 4 to pi over 4. And so that's the sine of pi over 4 minus the sine of minus pi over 4. And this is going to be 1 over the square root of 2 minus, and then this is minus 1 over the square root of 2. You could use a unit circle if you're not sure about that. And so that's going to be 2 over square root of 2. I guess if I multiply that by square root of 2 over 2, square root of 2, I get this is square root of 2. Okay, I ran out of paper on that page. I think we could probably finish these up. Let me pause for a second. All right, so it looks like we just have a couple of these left now to do. Let's see, we finished up with the cosine function, and so now we're at x to the e plus e to the x. Wow, that's really not coming in very clear, is it? Okay, I'll just rewrite these. The last one's not going to be on the quiz, although we'll take a quick look at it. So, next to the last problem is 0 to 1 x to the e plus e to the x. Good. So the antiderivative of x to the e will be x to the e plus 1 power. And then I need something to multiply by to get a 1 back, so I'm going to have a 1 over e plus 1. And then the antiderivative of e to the x is just e to the x. Everything's being evaluated from 0 to 1. So if I put a 1 in here, I get 1 over e plus 1 times e squared. No, wait a minute. 1 to the e plus 1. What's 1 to the e plus 1? That's just 1. Okay, plus e to the 1 minus, now I'm putting in a 0 in for x, and I'm going to have, let's see, 0 plus e to the 0. Okay, and so that's a 1. So let's see, we could simplify that a little bit, I think. What's 1 over e plus 1 minus 1? That's a e plus 1 over e plus 1. So it looks like that's going to be minus e over e plus 1. And then we have this plus e. Let's see, would it make sense to go ahead and make this into one fraction too? Oh, we'll just do some for fun. That's minus e plus e squared plus e divided by e plus 1. Okay, you probably didn't have to go that far, but you end up with e squared over e plus 1. Okay, that's kind of nice. The last one was the integral from 1 over the square root of 3 to the square root of 3 of 8 over 1 plus x squared. And if you look at our handout, you'll see that that's 8 times the inverse tangent of x, and that's running from 1 over the square root of 3 to the square root of 3. And so I think I'm just going to stop here. So that's 8 times the inverse tangent of the square root of 3 minus 8 times the inverse tangent of 1 over the square root of 3. And we could evaluate these, but I think for the quiz tomorrow we're not going to need to do that. So we'll stop right there. This one will not be on the quiz, not on quiz. Okay, those are the solutions to 4.4.